Good morning and welcome to the last assignment in this SPSS statistics workshop. We're going to be doing factor analysis this morning. Now, the specific steps that I'm going to give you might be a little bit different than some of the resources that I supplied, but let's do it this way because I think it's the simplest way to explain how to do a factor analysis. So up on your on the screen, you'll see that we have various assignments for this week, but I'm only going to require number one. The others you can do as practice, and it's basically the same thing, but we're going to do number one and focus in on that. So if you look at number one, we're going to be looking at questions number 1 through 23 and do a factor analysis to see which ones of these are better factors for determining the relevance of certain variables. And then once we do that, we might create another variable and then do a correlation within that variable to see if that can stand alone as a variable to add to our our questionnaire and variables that we could apply other tests to. So let's go through this. So how many new factors are going to be created? Which ones loaded up to each other? What's the total percentage of variance that was explained? And did any of these items not load up? And did we do a Cronbach alpha? We'll be doing that one toward the end too. Or I'll explain the steps as to how to do it. So let me get out of this and go back into SPSS. Let me bring that up. Okay, so if you look at the data file that you opened up for this week, if you look at the data view, and on the top the headings are questions 1 through, and you see that it goes all the way up to questions 23. Go to variable view, because when you select the variables, they're not going to be listed as questions 1 through 23. They're going to be listed by the labels. So you have to match it up. Questions 1 will be statistics made, and so on. All right, so here we're going to go to Analyze, Dimension Reduction, and Factor. Okay, so as you can see, I already put in all my variables here. These are all 23 questions. Okay, and these line up with the numbers. Like number 1 is this statistics make. All right, I'm going to go all the way down to 23, the last one being if I'm good at. Okay, you see that? All right, so from here, what we're going to do is to go to options. We're going to go sort by size. For rotation, let's do the direct oblimin, this one, okay? And go for rotated solutions, okay. Now, let's see, am I going too fast? No, I think we're okay. So let me show you the results. As I stated in the email, you're going to have, let's go down here. In components, you're going to have the exact same number of components as you have variables. So the temptation is to say, oh, so number 1 must be the first variable, and number 2 must be the second variable because it's 23. No, and it's not a coincidence either, but they don't match up 1-to-1 like that. When you put a scatter plot where all the data points are put on the scatter plot, the widest difference, the longest difference between the two values on the scatter plot will be component 1. You can draw a line between those 2 points, and the second furthest distance between the 2 points on the scatter plot will be component number 2. And you keep going until you get 23 distances between variables, and so you have 1 for each variable, 1 component for every variable. So they're different than the variable. Okay, and the reason that you're doing this is called dimension reduction in factor analysis. Is because you're looking at the same display of data but in a more efficient way. As I've heard it explained, it's like going to a movie. A movie traditionally is two-dimensional. You see it up on a screen. And if you pay extra for the 3D glasses, you might have another dimension, but it doesn't really add to understanding the story plot. You still see the actors, you still hear the audio, you still follow the storyline, and 3D doesn't really add to it. So 3D is an element of the data, but if you can reduce it and flatten it, like you wouldn't by just taking off your 3D glasses and watching it in regular 2D, you still follow everything. You don't lose anything. So that's what we're doing here. We're collapsing everything, we're reducing the dimensions so that we could identify the factors that really do explain a certain phenomenon that you're looking at. And you exclude others, and you're making it more efficient. Okay, hopefully that makes sense. So what we're doing here, this is one of the ones that you want to look at, total variance explained. And this will help you explain a couple of the, answer a couple of the questions on the assignment. You're looking at the eigenvalues. These are the eigenvalues here, where it says total. You have all 23 components, but the only ones that matter are the ones that have an eigenvalue of more than 1. Okay, those are the ones that are identified as true factors. The other ones contribute to a certain degree, but they don't contribute to the explanation of the variable as much as these 4. So the only ones that got 1 or more were these 4. So how many factors were identified out of the 23? Well, 4 of them, only 4. And then what percentage of the variance do they explain? That's this total number here that I'm pointing at, 50%. Okay, so number 1 explains 31%, number 2 explains 7%, 3, 5.7, 4, 5.3, and this is the cumulative effect. Number 1 by itself, number 1 and 2, number 2 and 3, and then 1, 2, 3, and 4, they explain 50.317 of the total variance in your analysis. So that answers one of your questions. Okay, so once you see that, these 4 represent the 4 components that were identified as factors. Okay, so now these are all the 23 variables. You recognize them because now it just spells it out. Now you want to know how many of these line up to each one of the components, or how many of them load up to each one. Okay, so if you're looking at the scatter plot again, how many of these line up or cluster around that line you drew between the 2 furthest points of variance? And this tells you. Okay, so you're looking at numbers that are either more than 0.03 or less than negative. Let me say that again. I think I said it incorrectly. You're looking for a number that's more than 0.3 or less than negative 0.3. So I'm going to let you guys interpret that. Look at number 1. Which of these are either more than 0.3 or less than negative 0.3? Okay. And I've even had students write a number line because it's hard to visualize sometimes what's less than 0.3. So you sketch out a simple little number line so you can make sure you don't make an error of what's less and what's more than negative 0.3. So those are the ones that cluster around number 1. Okay, the same thing. Which ones clustered around number 2? Same criteria. Which ones clustered around 3? Which ones cluster around 4? All right, so what you want to do in doing that is you want to do a Crohn's alpha analysis, and that'll help you determine if you can make a brand new variable. If you can make a brand new variable using this material. So let me recap. When you put all 23 in here and you do the factor analysis, it tells you that of all these 23, these 4 really contribute the most. So if you did a study and you have all these variables and you wanted to study a certain dependent variable, and you have these data in to determine some value to the dependent variable, this tells you that these 4 were really the most important in contributing to the value of that dependent variable, and to the value of your study, to the validity of your study. So these 4. Okay, so now you want to see, could I create another variable? How many from all of these will kind of cluster around these 4 that are the most valuable to me now? So these will tell you, out of the 4, which ones cluster around those. So you don't have to do all 4. You can do 1. So of these, which ones have a value higher than 0.3 or lower than negative 0.3. And make a little list of that, okay? Or identify them. Identify them. Then what you do, let me get out of here. Then what you do is you go to Analyze, go to Scale, choose Reliability, okay, and you put in only those variables that clustered around number 1. Okay, move those over to the right, and it's pretty straightforward. It'll give you a correlation coefficient. Remember, the closer to 1, the higher the correlation. So what would be acceptable is like, boy, even like a 0.7 would be an acceptable score. So again, in the table, look at the ones that clustered around number 1. You could do it for all 4, but do it. We're only practicing, so you'd only have to do it for 1, and 1 has the highest explanation of the variance. Remember, so to make it strongest, look at the ones that cluster around number 1, and then all the ones that cluster around number 1. Remember, 0.3 or more, or less than 0.3 negative. Find those here, put them over here, run this analysis, and if it's around 0.7, maybe a little bit more, there's a high enough correlation so that that in and of itself could be another variable. Okay, and we can stop there. What we would do there is rename that variable. There are steps to doing that, so that in your data file it would be added. So you would have questions 1, 2, 3, 4, 5 all the way to 23, and then would have another variable that you would label, with a completely different label. Why? Because that variable clustered around one of the components so well, and the value of that as a variable is so high that you can add it as another variable to your study that you can analyze. Okay, so suffice it to say, what I want for this assignment are all the steps that I asked you to go through. Explain the tables following the assignment, and the very last step, the purpose of doing the Crow-Bound AFL is to see if you can create yet another variable by doing a analysis of correlation just for those sets of those variables within that one component. So you can make another variable to add to your data set. So hopefully that made sense. And if not, text me or email me, and maybe I'll do another video to clarify it. But I think this is pretty straightforward, and do only one assignment. Only one's required. The other ones are practice. Okay? Well, good luck. Thank you.